Hello everyone, and welcome to this weekly session that we conduct, Ask AuxEn Anything. And as you all know, that this is an online platform for civil structural engineers to interact with us and ask their doubts or queries that they may have related to any RCC steel design concept or any project that they are doing or construction site issues. So this is the 67th such episode that we are conducting, and we'll begin by taking the queries that have been asked for this week. So I'll start by taking the queries from Google Form, and then we will take the queries from the live audience and emails. Okay, so let us begin. First query for this week has been asked by engineer Sonu Mewada. He is from Ahmedabad and he's a working professional. So he's saying, in PEB in PEB design, some designers are using AISC 710 edition. The current edition is 22 with ASD design method in which they are not taking any factored design combination. Is it okay to follow the same practice in India also? So see, if the AISC 710, I think you need to check what is the return period that they have used for wind and seismic. You check that first. Wind and EQ, what is the return period that they have used? Because I think in AC 710 they made that change and they started using a higher return period for their lateral loads. And because they started using a higher return period for their lateral loads, they changed the combination factor in the ASD combination. Sorry, in the ASC combinations. First of all, it's not AISC, it is ASCE, ASC 710. So the point is, as long as you are taking the loads and load combinations from one code, then it is okay. All right. That means if you are taking the loads also from ASC 710 and load combinations also from ASC 710, that's correct. Do not do it like this, that you are taking the loads from IS 1893 or IS 875 and then you are using the combinations from ASC 7. That will be inappropriate, incorrect also in some cases, because in the later versions of ASC 7 they have changed the return period, so it will be incorrect in that case. So as long as you are taking the load combinations and the loads also you are calculating as per the ASCE code, you can go ahead. But do not do it like this, that you are taking the loads as per IS 875 or 1893 and then taking the load combinations as per ASC 7. That is incorrect. Okay. So if doing, then what is the design consideration? My only thing is, do not do it. Do not do. Take the loads also from 1893 or 1875 and load combinations also as per the Indian code. Do not mix, because it is a potential, I would say, a potential, uh, you will create a potential chance for committing mistakes. So do not do it like that. Okay. And for detailed explanation to a similar query, just go to the Ask AuxEn Anything session number 65, I think, where we have explained this in greater detail. So you may have a look at that episode also. Short answer to your query: do not mix and match. It's uh, it's incorrect. Do not do it. Okay. Then next query is from engineer Rohit Dogra. He is from Himachal Pradesh and he is a working professional, and he is asking, Kindly explain the appropriate property modifiers for retaining walls and shear walls, including which modifier should be used and the reason behind selecting those values. So, as far as I remember, your IS 16700 does not. Uh, Let me just open and check, but I think it does not explicitly give you modifiers. I'm just checking the modifiers being given. So yeah, so it does give you these modifiers. So this is the table from 16700 I have just copied. Okay. So for retaining walls and shear walls. Okay, so for walls, it is giving you, if you are doing the strength based design, it is giving you this modifier. Okay. Now walls are, remember these walls are your RCC structural walls. And these modifiers are the modifiers for moment of inertia. So they are to be sort of assigned to your flexural action, or let's say the moment of inertia has to be reduced by this value. So you may use this for shear walls, uh, including which modifier should be used and the reason behind. So reason is this code has given you this value, use it. For retaining walls, in retaining wall, what happens that the walls are expected to take out of plane loads. So when it is expected to take out of plane loads in retaining walls, I will just use the ETABS sign convention and local access convention right now. Most of the times in ETABS, your local access 1 will be like this, local access 2 will be like this. So if it's a retaining wall that you are using, then you assign M11 and M22 modifiers as 0.7, because in retaining walls you will have out of plane moments because the load is perpendicular to the plane. So you give that. Now, if this is a RCC shear wall, then what do you do? That shear walls are, they technically take the in plane loads, in plane moments. Now, in plane moment, you cannot directly specify by this M11, M22, because M22 are out of plane moments. So, therefore, in shear walls, you may give the F22 modifier. So, the reason for giving F22 modifier is that the moment can also be thought of as being taken by this tension compression couple. So, you are effectively trying to reduce this tension compression couple, and indirectly, therefore, reducing the in-plane moment of inertia also. So therefore, you give F22 as 0.7, and there are chances of in-plane moments. Sorry, there are chances of out-of-plane moments also. Uh, Out-of-plane moment is also possible in your shear walls. So you give this. I'm just thinking, yeah. You give M22 modifier also because there is an out-of-plane moment also possible about the vertical direction. So about the vertical direction, there is an out of plane moment possibility. So you give M22 modifier also as 0.7 when it's a case of RCC shear wall. So these are the values that you can assign. Okay. Right. Then what was your next question? Please explain the floor area ratio provisions and the fire rating cover requirements for structural elements as per relevant codes and standards. I don't know. I don't know. You need to look for some documents on your own. I'm not sure about the FAR provisions and the fire rating cover requirements. I think in ACI 318, it does give you some information about the fire rating cover, concrete cover requirement. However, I do not know. You need to look into it yourself. Okay. All right. The next query has been asked by engineer Ravi Chandra. He's from Hyderabad and he's a working professional. So he's asking, many engineers are assigning temperature loads on shear walls. My question is how temperature effects will consider on shear wall. It is purely compression member. In my view, temperature load has to assign on flexural member. Kindly correct me and give guidelines for this temperature load. See, temperature load should be assigned to those elements which are supposed to be exposed to the changes in atmospheric temperatures. So, in my opinion, temperature load should be assigned to those elements which are exposed to the changes in temperature. So, uh, that element which has a large surface area and which is exposed to your direct sun, let's say, are your slab elements. So, in my opinion, temperature loads you should assign on your horizontal slab elements, and then depending on the expansion contraction of your slab, those stresses will then be transferred to your other members. So any internal force that is generated in those members, it will be due to the expansion contraction that is experienced by these members. So my opinion is that you should assign the temperature on your slab elements, the horizontal elements which have first of all the largest surface area and which are exposed to sun or exposed to temperature changes, and then upon applying those loads you can then, then the software on its own will, due to these changes, will transfer, so to say, the forces to these other elements. Mr. Aditya Raj Mehra is asking calculation of temperature load and how to assign. Mr. Aditya, I think in the steel design course that you have taken, we have discussed the application of temperature loads. So you may refer to those sessions. There is a method that is given in IS 875 Part 5 where we assign the temperature loads which will create expansion and which will create contraction over and above the ambient temperature. So there is that method. And there's one more method given in your IRC 6. IRC 6 is a code for road bridges, but still you can just have a look at the method that is given. So you go through those methods, and if you have any specific query, then you may ask. Then the next question is from, okay, no, Mr. Ravi has another query. In wind combined peak, in wind, there should be a comma. Combined peak acceleration means square root of both along and across wind acceleration, or what? Kindly clarify. No, across is across, along is along. You do not take a square root of these. So basically, you will find the peak acceleration in both directions, in the along wind response also and in the across wind also. So those two are two different values that you will calculate. And then there are guidelines given for along wind and across wind. So those two are separate set of combinations. Those two are separate accelerations. You do not combine them together. They are two different entities, and there are limits given for both of them, which you will check. So in the tall buildings course, we have done these calculations in great detail, and you are already part of that course. So you may have a look at those sessions where we have discussed the gust factor approach for wind load calculation. Next set of questions is from Engineer Rais. He is from Srinagar and He's from Shupian and he is a working professional. So, what is his query? Consider a building on slope in seismic zone 5 with SBC not greater than 30 tons and N SPT value is around 20. Consider the slope in such a way that there is a difference of around 5 meters. Two cases are there. If we give foundation at two or three different levels, then execution is easy and economical. Although foundation passes all checks, settlement, this. If we do this, will this create overturning or distress in global behavior? In other case, if we give, so he is asking that he is a slope structure and uh, the level difference between this slope is, let's say, 5 meters. In one of the situations, what I have understood is that he is, let's say, giving the footings on different levels. Those footings are passing all the checks. So one footing he has kept like this, and it might be that he's keeping, let's say, more than two footings at one level. Then he's making a step and then keeping the keeping one footing over here and like this, and then this is your common, let's say, ground level, and then above that everything is then following one standard level. So in this case he's saying that this is more economical execution wise. All the footing sizes are passing the checks, etc., etc. Is it okay, or should he go for or should he go for a scenario where it will be required to excavate to a general common level and then give all the footings at one level? That is his query. This will be problematic in terms of execution, because then there are large excavations that are involved, so you will have to excavate all this, and here the excavation was only this and this. So which one is better? uh, So if, because in your case it's a soil that is not having a good bearing capacity, it's 13 tons per square meter, not very high. SBC is not very high and the N value is also not very high. Also you are in seismic zone 5. So this is not a hard strata, and uh, it's a strata which is prone to problems because of high seismicity also. So this type of situation is not recommended. This is not recommended. No, there are multiple problems over here. The problems are that this footing will be very close to this edge. So because of the bearing pressures, there is always a tendency of this soil collapsing. So then here also, I assume you have not considered the requirement for retaining walls on these edges. And when you start considering the requirement for retaining walls, then automatically your costing will also go up. So I think when you are saying that this first option is economical, I am assuming that you have not considered the requirement for these retaining walls that will be needed, because naturally this slope you cannot keep it as a straight face. It will be not recommended, and you have to stabilize it using retaining walls. And compared to that, this is much better option because you are now getting a same level. So the local slips or local collapses have been done away with. You are reaching to a common datum and providing your footings. So here the need for retaining walls is also done away with. You might need a retaining wall on this edge, that's it, but otherwise there is no requirement for any retaining structure as such. And you have achieved a common datum also, and plus there are no chances of local slippages occurring. So this case 2 is much better than case 1. And when it comes to safety, economy, see, economy for an unsafe structure carries no meaning. So, case one is no, no. Do with case two, that is better. 5 meter level difference is not much. So, case two is the one I will recommend, and not case one. Okay. The next query is from engineer Sai Leela. The question is need to learn full pipe rack and steel building design. So we have done a lot of good courses on steel structures using American codes, Indian codes, different type of structural systems. So you may message us on WhatsApp and I'll guide you further for which is a suitable course that you may take based on your requirement, whether you need to learn steel structures based on Indian codes or American codes. Okay. All right. So these were the queries asked on the Google form. And now let us take the queries from the live audience. So the first query is from Ram Vishnudev. I hope you are doing great. I have one question. If the vertical member ratio is less than 4, for example, 1000 mm by 1500 mm, when I model it as a line element, it gives more PT. If I model it as a shell element, it gives less PT. What is the correct approach for design of such big column element? So 1000 upon 1500, your uh, sorry, 1000 upon 1500 B by D. So what is the B upon D coming? 0.67. So it is greater than 0.4. So technically you're allowed to have it as line element if you just read the codal requirements, because code says that if your B by D ratio is less than 0.4, then you should consider it as a RCC structural wall. Otherwise you're allowed to consider it as a column or a line element. So he has made a very appropriate observation that just a minute. Yeah. So why do you get these differences? The reason for getting these differences is because when you model it as a shell element, the distribution of forces is different, because in shell it is connected at more number of points with your slab element. Okay. And because of that, the distribution of forces will slightly vary. And when you model it as a line element, it is only at a point where your all the slab elements are connected. So in this case, the localized forces are more, and that is what you have also observed. So your observation is all right, that when you consider the model it as a shell element, you may get lesser forces and movement. Generally, it will apply. Generally, the difference will be with the moment values and not so much with the actual force values. So see, most many consultants, what they do is that when they have such large columns, they will make two different models. One by modeling the column elements as shell elements, and one by modeling the column element as line elements, and then giving the larger percentage from whichever case they get it. So It's not about any correct approach, but if your columns are so big, and naturally it means that it's a it's an important sort of structure that you're doing, which is having such large columns. So you may perform this exercise 2 times, and by performing this exercise 2 times, that is once modeling the column as a line element, once modeling the column as a shell element, then the higher percentage whatever you are getting you may provide. Okay, but your observation is correct, and this happens due to the way in which the connection happens between the shell elements and the line elements, and uh, when you model it as a column between the shell elements, sorry, when you model it as a RCC shear wall, then the connection that happens with the slab, shell elements, and shell elements of the walls. So because of that difference, you have observed the differences in moments, because of which the percentage PT slightly changes. Okay, the design process remains the same, but what changes are the moment analysis, moment values, and because of that, you see the difference in percentages. Okay. Then engineer Sujoy Patra is asking, is it okay to certain ignore certain kind of warnings such as too close members or joints, where it shows okay in 22.0.7 but errors in ETABS 19? No, so you should be checking for the tolerance of around 25 to 50 mm. So in this tolerance limit, you should check and see if there is any presence of any duplicate nodes in this sort of tolerance value, and if there are any warnings, or there are any warnings that are given by ETABS, that means there are some modeling issues which you need to rectify. Mr. Vineet Kawadi is asking how to design pedestal supporting steel column. Just like you do your normal column design, in the same manner you have to do pedestal also. Pedestal is nothing different as compared to your columns. It is the same thing. You need to design your pedestals for the moments and axial forces. Generally, slenderness may not be a problem in case of pedestals. So uh, you may do it. I mean, the slenderness moments may not be a problem, and uh, you can do it using the SP16 method also. By using hand calculations, you can do the pedestal design. The process remains the same, because it is also a column that has to be designed for axial loads and biaxial movements. Mr. Sujoy is saying, I took a tolerance of 1 mm. See, if you're taking tolerance of 1 mm, the possibility of having duplicate nodes in a 1 mm region is very low. So you might not get any errors. So take a tolerance of 25 to 50 mm, because then if there are duplicate nodes in this region, you would be shown warnings for that. So take a tolerance of around 25 to 50 mm. First, understand what is the meaning of tolerance. We have explained this in our course on RCC design. Tolerance means that when you are checking for presence of duplicate node, this is node, and by mistake you have made a node over here. This is mistake. By mistake you have modeled another node. Now if this is at 100 mm away that you have modeled this node, and you give a tolerance of 25 mm, what will happen? That ETABS will only check in a radius of 25 mm for any duplicate node. If it gets a duplicate node in this region, it will give it as a warning, otherwise it will ignore. So if you are giving very small tolerance, it will only search or look for a presence of duplicate node in that small region. So why did I say 25 to 50? Because chances are very low that you on purpose made any node 25 to 50 mm away. It must have been made by mistake. That's why I took this tolerance value of 25 to 50 mm. Okay. So these are the queries that we will take for this week. I have to go somewhere, so I'll close today's session over here. If you have any more queries, you can just put your queries in the Google form, The link remains the same, and you can keep putting your queries in the same Google form. And once every week when we meet, we take up your queries. And if you want to connect with us on WhatsApp, then this is the link to connect with us on WhatsApp. So I'm just putting that link over here. So this is the link for connecting us on WhatsApp. Mr. Ram is saying as shear wall ratio is length of wall by thickness, ratio is coming 1.5, but as line element it's giving 5%, and according to architecture purpose, I am not able to increase. I did not understand the first statement as shear wall ratio is length of wall by thickness. No, no, no. You look for the rho T value. You look for the percentage of reinforcement value that is being shown. Longitudinal reinforcement percentage in shear wall. Mr. Ajinkya is saying tolerance given with 1 mm shows more warning than 25 mm. No, it won't happen. It won't happen that way. Tolerance of 1 mm, if it is giving you warnings, that means within 1 mm you have placed multiple nodes or multiple errors. 25 mm tolerance should cover 1 mm tolerance also, yes, but it does not. No, I don't think this statement is correct. Tolerance with 1 mm will not give you more warnings. A higher tolerance will give you more warnings. If at all there are presence of duplicate nodes, that is. So you just check once again. Okay. All right. So uh, yeah. So this is the link if you want to connect with us on WhatsApp. We will close today's session over here, and we will meet you once again next weekend. So till then, have a good time, and yeah, bye bye. See you next week now.